Okay, this is the video for 3.4b. So these are the notes at the end of your 3.4 section in chapter 3. And so they follow the notes from the earlier part of 3.4, but these ones focus on word problems. So I just wanted to go through these two word problems together, and then they can lead you into some of the practice in the textbook questions. The main thing that we want to do when we're looking at a question is we want to set up an equation based on the wording in the question. And so this question, if one more than 3 times a number is divided by the number, the result is 4/3. Lots of words, and it is fairly wordy. There's a lot going on there, at least at first glance. So let's try and break it down. One thing that we want to do, especially talking about this number, right? And you see that it's referring to a number over and over again. 3 times a number is divided by the number. The result is 4/3. Find the number. So there's this number that's existing. We want to find this number. And so what we're going to do is we're going to say that the number is x. So even right off the bat here, we say let x represent the number. How do you spell represent? So the number that we're trying to find, x is representing that. Let x represent the number. The next thing we want to do is we want to find the place in the question where it talks about the equal sign. So where does it say that something equals something else? And the wording of the question will often be is, or results in, or the result is. And in this question we see that it actually says the result is. So right here, this is our equal sign. Okay, so if we put an equal sign in the middle of our page, again, we're trying to develop an equation here. So we put an equal sign here. We know that the words that are before that part of the question are on the left side of the equal sign. Okay, the words that are after that part in the wording of the question will go on this side of the equal sign. So really, we're transferring the wording of the question into an equation directly. So if we look at the wording again, on this side of that part of the question referring to the equal sign. So on the left side of the equation here, if one more than 3 times a number, now remember, our number is x. Okay? If one more than 3 times a number, just going to write that below here, is divided by the number, and then we don't even have to read the rest of the question right now. We're just focusing on the left side of the equation. If one more than 3 times x is divided by x, one more than 3 times an x. So let's look at the x right here. What's happening to that x? Well, it says that we're multiplying it by 3. 3 times x. It says that right here. 3 times x. So we know we have a 3x here. What else do we have? Well, it says if one more than that. So we've dealt with the 3 times. It says one more than 3 times a number. So how do we represent one more than? Well, we add 1. If one more than 3 times the number. And we can look at what we have here, and we can see that that represents that sentence. What we're missing, though, is this last part that says is divided by the number, divided by x. So there's this part here, it's divided by x. That we still need to take care of. So that whole expression is divided by our number, divided by x. One more than 3 times a number is divided by x. Now, let's look at the other side of the equation. So we've dealt with everything on the left side of the words the result is. So the left side of our equation. Now we will deal with everything that's on the right side. So that would be right here. The result is 4/3. That's obviously a lot less complicated because it tells us that the result is just that one piece, 4/3. So we will write that on the right side here, 4/3. So we'll review the equation now. If one more, so we're talking about adding, one more than 3 times a number, 3 times x, is divided by our number x, the result is 4/3. So we see that the wording of the question, it is wordy, and we've spent a lot of time kind of trying to decipher that, but it does follow an order. We can read the question and take the pieces directly from the wording and put them right into our equation, really from left to right in a lot of ways. So all that's left then, once we have the equation, is to solve it. We have the equation, now let's solve the equation. So one thing we talked about in our previous video in 3.4a was that we can multiply our equation now by a lowest common denominator, all right? That's what we'll do in order to be consistent with the way that we looked at the previous examples. In this question though, because this is what's called a proportion, we have a fraction equaling another fraction. You could use cross multiplication or other methods in order to solve for our variable here, but we will be consistent with the way that we did this in 3.4a, and we will multiply by the lowest common denominator throughout the equation. So that's what we will do in this question. Not the only way to do it though. So the lowest common denominator, we look at our denominators here. We have an x and we have a 3. And so our lowest common denominator is just those factors, 3x. So we multiply the first term on the left side here by 3x. It's the only thing on the left side of the equation, right? It's the only fraction. And so we just multiply that by 3x. We multiply the right side by 3x. And again, it's only one fraction there. We only multiply once by 3x. And that's happening in our numerator. And so if we have an x in our numerator here on the left side, it cancels with the x in the denominator. Now be careful to leave the 3 on the top right here. But the x cancels. So we're left with, on the left side of our equation, we have now the 3 that we're multiplying by and the 3x plus 1 that was there to begin with. On the right side of the equation, we notice what happens. It's the 3 that cancels, and the x is left behind. So what we have is we have the x that we're multiplying by multiplied to the 4 that's there already, so we can write that as 4x. The 3's cancel, we're left with 4x. So again, now we have an equation just without our denominators, and we can solve this just by simplifying and isolating x if possible. So 9x plus 3 equals 4x. And so getting all the variables on the left side, we'd have 5x then, because we subtract 4x. And then we move the 3 to the other side by subtracting. And so we have negative 3 on the right, and we divide both sides by 5. So we get negative 3 over 5, negative 3/5. All right? The question here does not ask us to consider non-permissible values, but we still need to make sure that this is a viable answer. So if we look back up here at our denominators, the only non-permissible value here would be based on that x there. X cannot equal 0. And our solution, our potential answer to the question, is not 0. It's negative 3/5. That works. So we're fine as far as our non-permissible values go. So we know that our answer is negative 3/5. So I don't need a sentence from you, but I do need you to answer the question. And we'll look at the next example is not as straightforward in the answer. And so we'll look at what I would require there. Even here, just to say the number is negative 3/5. So I guess that's a sentence. But something that tells me what your answer is. If you circled this here, I guess that would probably be okay. But in the second question, it won't be. So just make sure you pay attention to that. Okay, so moving on to the second one. Again, most of the battle here is to decipher the wording in the question in order to set up our equation. So in this case, again, we want to say, well, what's our x going to be, or what is x representing? So it says, find two consecutive integers, two consecutive numbers, we could say, if the sum of their reciprocals is 21 times as large as the product of their reciprocals. Again, that's fairly wordy, so let's try and break that down here. We have, we're looking for two consecutive integers. So just right from the beginning, let's decide what x will represent. If you notice, we're trying to find two consecutive integers. Well, what does consecutive mean? Consecutive means one after the other. So if I'm talking about the number 1, the next consecutive integer would be 2. If I'm looking at the number 15, the next consecutive integer would be 16. Okay, so if we let x represent the first number, we have to consider, well, what's going to represent the second number? We don't want to say something like y, because that introduces a second variable into our equation, and that's going to make it difficult for us to solve. What we want to do is represent this in terms of x. How does our second number relate to our first? Well, the second number is just one more than the first number. In both cases that I have outlined here, but if other examples you think of, if we're talking consecutive, the second number is just one more than the first number. So our second number is going to be, oops, I'll write that here. I hope you heard the bell there. You'll have to stick with me past the bell. The second number is going to be x plus 1, right? One more than the first number. So there's the idea that where we're talking about consecutive integers. So just another note on consecutive numbers then. There might be a question where it says two consecutive even integers. So if you have something like this, just a side note here, if it's saying two consecutive even, well, then you know that an even integer has to be 2x, 2 times a number, right? And so you could be dealing with something like that. So just to note, if it's talking about even integers, you want the number, but then you want to double it because it's got to be even, so it has to be a multiple of 2. So if you have specific questions on that, if that comes up, feel free to let me know. But back to this question, if we have two consecutive integers, so just one number apart here, x and x plus 1, then we can continue with the rest of the question. So remember we said we're looking for the wording in the question that represents the equal sign. In the last question, it said it results in. In this question, it doesn't have that. We see that as we're reading through, the sum of their reciprocals is, and that's the only time it mentions is there, that's our equal sign. So in the last question, it had to do with the result, results in, or the result is. This one says just is. So we know that's our equal sign. So when we're writing our equation down, we know anything that is leading up to that word in the question is going to go on the left side of the equal sign here. So this information here goes in this spot here. This information after it, so the stuff that follows it, is going to go on the right side of the equation. And so that equal sign acts as, the word is, acts as the equal sign in the wording of the question as well. Let's go back up to that point right there. So the sum of their reciprocals, that's all we're going to focus on right now because it's on the information leading up to the equal sign. It's going to be on the left side of our equation. So if we think about what reciprocal means, it means the flipped version of that number. So if we're talking about these two numbers, x and x plus 1, the reciprocal of x is 1 over x. The reciprocal of x plus 1 is 1 over x plus 1. So we're flipping that number. Instead of x, it's 1 over x as the reciprocal. And what's happening with those? Well, it does mention right here that we're talking about the sum of their reciprocals. So we're going to be adding because we know that sum is the word indicating addition. Okay, the answer of an addition statement. So the sum of their reciprocals is, so we've captured that information on the left side of the equation. Now we can look at what's on the right side of the equation. So again, we have the equal sign. Let's look at the wording to the right side of that word. 21 times as large, so there's a multiplication, 21 times as large as the product of their reciprocals. So 21 times as large as the product of their reciprocals. Well, we're back to their reciprocals, right? Only this time we have the product instead of the sum. We'll talk about the 21 in a second. So the product means that we're multiplying these reciprocals. So we have 1 over x and 1 over x plus 1, but we're multiplying them instead. And if you notice the 21 here, it says it's 21 times as large, or 21 times larger, it could say. So we have to multiply this then by 21. So the sum of their reciprocals, that's this right here, is, so there's our equal sign, is 21 times as large as the product of their reciprocals. And that's captured right there. So again, we're looking for that word is, where that's our equal sign, and then we can focus on the wording before the equal sign, the wording after the equal sign, to lay out our equation. Once we have our equation, we can go ahead and solve it. So we might as well do a little bit of simplifying on the right because of all that multiplication there. And then we can deal with the equation as we were doing before. So we have 21. Remember, this is kind of like 21 over 1 here. So 21 times 1 times 1 in our numerators. And then on the bottom, x, 1 times x plus 1. We can multiply x and x plus 1. But we want to know our factors anyway. Remember, factoring is a big part of what we do to start our equation solving. So we want our factors anyway. Instead of multiplying these two factors together, we're going to leave them as factors because that way our lowest common denominator is easier to identify. And so solving our equation, what is our lowest common denominator? Those two factors, x and x plus 1. We see those present on the other side of the equation as well. And so we know that our lowest common denominator involves both of those. So let's multiply each term by that lowest common denominator just the same way as we have before. And we have that multiplied to the numerator in every term. And the whole reason why we do this is so that we can cancel out factors here. So x and x cancel in the first expression, leaving us with the x plus 1 times 1, but that just remains x plus 1. In the second expression, the x plus 1 cancels, leaving us with x times 1, but we don't have to write the 1, so just x remains there. And in the other side of the equation, the third expression, the x cancels, and the x plus 1. So we're left with 21. So we see that we have an equation now without any denominators, and we can use conventional methods of isolating x to solve. So 2x on the left side, once we combine like terms, we bring the 1 over to the other side by subtracting it. So 2x equals 20, and then we divide both sides by 2, x equals 10. So the solution to our equation is 10, but it may not be the answer to our question. So let's just make sure it's not a non-permissible value. And so we're looking back up to here. We see that our non-permissible values would include these factors. And so we can see that 10 is possible, 10 is allowed, it's permissible. So we're fine with our number 10. But let's just see what question we're answering to begin with. Find two, let's see up here, find two consecutive integers. Well, x is the first one, x plus 1 is the second. So if we just say that our answer is 10, that's not quite answering the question, because we need two numbers. So if x is the first number, that means that the second one is 10 plus 1, x plus 1, so 11. So we have our two numbers that answer the question. The first integer is 10, the next consecutive one is 11, because of the x plus 1 idea with consecutive numbers. So there's two examples on word problems, and again, I'll post some questions that will allow you to work on some similar things, and let me know what questions you have on the notes or on the questions themselves from the textbook.